question 5 in your study guide. So here we have to write a system of equations again. Marnie can attend 2 different carnivals. Carnival A charges $6 for admission and $1.50 per ride. Carnival B charges $2.50 for admission and $2 per ride. So if you notice, these equations are in slope-intercept form. Okay, so we're looking at this as the initial value and the rate of change. Okay, so I see 6 and $1.50. I want to make sure that I'm using this correctly. It looks like 6 is admission, so that's something that I spend once, and $1.50 is for each ride. So if I go on 1 ride, I spend it once. If I go on 2 rides, I spend it twice. So we're multiplying $1.50 by our variable, which is the number of rides that we go on. So if you look at the first one, you have initial value of 6 just one time, and $1.50 multiplied by x, the number of rides. So that looks correct. Let's check if the second equation works for the second carnival. Well, that one says $2.50 for admission, and we see that, $2.50 by itself. Initial value, something you spend once, and $2 per ride, 2 times x. So choice A has that correctly. Okay, now question 6 follows. It's on the same page here because it uses that system. Uses system of equations from question 5 to determine exactly how many rides Marnie could go on to pay the same price at both carnivals. So if we're trying to figure out a number of rides that's the same amount for both carnivals, number of rides was the x, right? We multiplied the price per ride by x, so x is the number of rides, and we want to have the same price. We're looking for a solution. So there are many ways you can do this. My students actually chose to do it on the calculator. For the sake of the video, I'm not going to use the calculator because I don't have our graphing calculator here. I'm going to use substitution instead. So I'm going to copy this over. Y equals 150 x plus 6 and y equals 2x plus 250. Again, if you wanted to use a calculator for this, go ahead and do it. For the video, I'm going to show you substitution. So, and you can check if you get the same answer as me, and then you're fine. So I see something equal to y. I can substitute it into the other equation for y. So now my equation looks like 150x plus 6 equals 2x plus 250 because I replaced y in one equation with the expression equal to y in the other equation. Now I can solve this. Whenever I solve, I always like to first get my variables on one side. Okay, so I'm going to subtract 2x here. 2x minus 2x is 0. Subtract 2x here. 150 minus 2 is negative 1/2. Okay, negative 50 cents, right? If I have $1.50, take away 2. So negative 1/2 x plus 6 equals 250. I'm going to rewrite this right here because I'm running out of space. Now I can use inverse operations. I see x is multiplied by negative 1/2, and then we're adding 6 to that. Opposite of add 6, subtract 6 to get 0. We'll subtract 6 here. So I have negative 1/2 x. I have 250 minus 6, which is going to be negative 350. You can use a calculator for these if you're not following all of that. Feel free to pause at any time and just try it on your own and make sure you're getting the same thing as me. Okay, now I have x times negative 1/2. I'm going to divide by negative 1/2. Okay, and when I'm dividing by negative 1/2, you can use a calculator, but if I think 350 has how many groups of 50 cents, that's 7. Okay, so I have x equals, and is it positive or negative? Well, a negative divided by negative is positive, so x equals 7. So that means that after 7 rides, she will spend the same amount of money because our solution is 7. Okay, x was 7 and x represented the number of rides. So after she goes on 7 rides, she'll spend the same amount of money whichever carnival she goes to. Now use the system of equations and determine what the price will be for the number of rides that you found in the other question. So now we want to take the same equations. I'm going to use the second one, 2x plus 250, and say, hey, well, how much is she spending on 7 rides, right? We want the other coordinate to the solution. The x coordinate was 7, and that represented rides. Now we want to plug that into the equation and see what y equals. What is the total amount of money she spends for those 7 rides. And